Welcome to section 7.1. We're dealing with exponential growth, and I'm going to start by giving you the equation for exponential growth, and I'm going to put it in this middle box. The equation for exponential growth is y equals a times b to the x power. So our exponent is going to be where our variable is, what we're trying to find. If it is growth, then our value of b, okay, where b has to be greater than 1. We're going to deal with decay tomorrow, so the value of b will change, but for today the value of b is greater than 1. Let's make that a pretty clear b. Okay? We're also going to be talking about today, I'm going to fill in this is about section. We are going to be graphing exponentials. Okay, and exponentials are just a type of graph. Like we say we graph lines or parabolas. Exponentials is a different type. And it's a function that looks like this. Y equals a times b, and then in parentheses we have the x minus h plus k. And so we're basically going to be transforming this like we did absolute values, like we did parabolas, things like that. And so this is kind of important as we go through. So we're going to start first with this graph example number 1. And I'm actually going to rewrite this a second. I'm going to say this is 1 times 5 to the x. And the reason I'm doing this is because this 1 is pretty important as we go through. And I'll show you that. What we're going to do is make a table. Okay, and for our exponentials, we're going to start with the basic -2, -1, 0, 1, and 2. Now for today, I'm actually going to show you how to do 90% of this lesson without your calculator. Those of you considering pre-calc or signed up for pre-calc next year, you won't get your calculator. So I'm going to start getting you into that idea. Now let's talk about exponent rules. I'm going to start with the 0. 5 to the 0 power is 1. Times that by 1, you get 1. 5 to the first power is 5. Times that by 1 is 5. Okay, 5 to the second power is 25. 25 times 1 is 25. And so positive exponents, I think you can do first power, second power, things like that. Let's go back and talk about negatives. If you take a negative exponent, it's a reciprocal. So 5 to the negative first is 1/5. It's the reciprocal of 5 to the first. And 5 to the negative 2 is 1/25 because it's the reciprocal of 5 squared. Okay, now what I'm going to do is graph these. I have this nice point 0,1 and I have a nice point 1,5. Obviously 225 can't get on my graph. 1/5 is about 0.2, so that's going to be like here, and then it's going to get closer to the x-axis. And if I did 5 to the third, it'd be 1/125. We're still not at 0, and what you're going to see is all of these points get closer and closer and closer to 0. And so this curve, this exponential, you will see it grows, it's small, and then it gets bigger. This is the graph of our exponential. Now I'm also going to change colors because I want every graph to include an asymptote. And an asymptote is kind of this dotted line that we put in, which means your graph cannot touch this. Okay, and so this is our asymptote. And our asymptote in this case is at the x-axis, although we're going to get out of saying x-axis and we're going to use the equation. The equation for the x-axis is y equals 0. And so that's our asymptote. And you'll notice the y values will never touch 0. They'll get smaller and smaller and smaller, but won't actually touch 0. Every graph must have an asymptote. Okay, if you look at the y-intercept, it's where the graph hits the y-axis, and this is my y-axis. So it's this point right here, which is the point 0,1. And what I want to show you is this 1 value here is exactly the number that was in front, or our a value. And so I'm going to add that up here, where my y-intercept is the point 0a. Okay? We also are going to talk about domain and range. Domain means what x values can we put in. We'll take a look. Here's how I look at domain. Did I put in a negative? Well, sure I did. Did I put in 0? Yup. Did I put in a positive and still get answers? The answer is yes. If I put a -0 and positive, then my domain is all reals. And we shorthand that with an R with like a double bar in front. Okay? Range is the y values. So I look at the graph and I say all of my values are up here above the x-axis. So the question is, how do I say above the x-axis? Well, it's above the asymptote of 0. So we say all reals above or greater than the asymptote value at 0. In this case, there is no transformation because our a value is 1, and I don't have anything up with the h or in the back with a k. So this is the basic, this is what we call a parent function. Okay, the parent function just means it's a b to the x graph. So y equals b to the x, where there's no shifting as we go through. Okay, so this is the first example. I want to walk through a couple more with you, and then I'm going to give you guys one to do before you come to class tomorrow. I'm going to slide this down to example 2. As I look at this, you'll notice now I have a value in front, 3. Again, this is my a value, and my a value helps me tell my y-intercept. Now, if you didn't remember that, let's make a table. And I'm going to pick my trusty values of -2, -1, 0, 1, and 2. And I'm going to go with you in order here. Let's go to the 0 power first because that's the easiest. 2 to the 0 power is 1. 1 times 3 is 3. Here you'll notice is my y-intercept. So 0, 3, I'm going to put my dot already. Let's go to the first power. 2 to the first power is 2. 2 times 3 makes 6. 1, 6 is like up here, but we'll put it up. 2 to the second power is 4. 4 times 3 is 12. That one I obviously can't get on my graph, which is okay. Let's do reciprocals. 2 to the -1 is 1/2. 1/2 times 3 is about 1.5. And I know you guys probably prefer the decimal over 3/2, which is fine. 2 to the -2 is 2 squared is 4, so the reciprocal is 1/4. 1/4 times 3 is 3/4, which is 0.75. And that's like here. Okay, and again, if I kept going, what you would find are values keep getting smaller and smaller, but again, they're not going to touch the x-axis. So I'm going to change my color again, and I'm going to draw in my asymptote, and I always suggest making this another color. I actually use a highlighter normally when I'm doing this so that I know don't touch the x-axis. Because this is the x-axis, our asymptote is y equals 0. Okay. Our y-intercept we said was this value of 3, so 0, 3. We always want to write this as a point. Domain, I'm going to ask you the same thing. Did you put in a negative? Yes. Did you put in 0? Yes. Did you put in a positive? Yes. If you can say yes to all 3, my domain is all reals. Where is my graph as we talk about the range? It's above my asymptote. Okay, so my graph, and maybe you want to make a note, is above my asymptote. I'm going to shorthand this a second. If I say above my asymptote is at 0, so above 0 means all reals greater than 0. Now, this one does have a transformation because there's a number now in front. And so that number in front, we want to discuss kind of what happens. My normal x or y-intercept is at this point 0, 1. You'll notice that this new y-intercept is farther away from my asymptote. And so if it's stretching, it's going farther away, we say that's a stretch of 3. Because it's stretching, the graph is stretching farther away from this asymptote line. Okay, it's stretching farther away. All right, let's slide over. I'm going to go up to the top one number, example 3. And then what we'll do is I'll have you do example 4 on your own. Okay, take a look. -4, ding, 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 that tells us our y-intercept. So 0, -4. And I'm not moving my graph. There's nothing in the h and k. There's nothing up here or back here, which means my asymptote is still going to stay the x-axis. So the y equals 0 line. Now, if you notice, my normal intercept is going to be at 0, 1. This is where normally I should have that y-intercept. So let's talk about what's different. Can we describe this first? And I would expect that you could describe this after doing transformations earlier. One, it's no longer above the x-axis, it's below. So my first transformation is a reflection over the x-axis. Okay, that's the first part because it was above, now it's below. Also, a reflection would normally put it just at 0, -1, but you'll see it's stretching farther away. So this is also a stretch of 4. Okay, so the negative, this negative tells you it's a reflection. The 4 tells you it's a stretch. Now, if I were to fill in this table again to be able to see the whole graphs, we know 0, -4 should be my y-intercept. Let's do 1. 2 to the first is 2 times -4 is -8. So that's like way down here. Okay? This gets you 2 squared is 4 times -4 is -16. Obviously that can't be graphed. The reciprocal of 2 to the first is 1/2 times -4 is -2. I can graph that one. And 2 squared is 4, so take the reciprocal 1/4 times -4 is -1. And you're going to start seeing this graph. Okay? Now, domain, I still have positives, negatives, and 0. So my domain is all reals. This time, my graph is below my asymptote. And if it's below my asymptote, I say all reals less than, my asymptote number is at 0, so less than 0. It can't be equal to because, again, it can't touch my asymptote. Okay, so here's what I want. This question down here, this needs to be done, must be completed before class in order to get your notes points. Okay, so if you want points for taking the notes, I want you to try this one on your own. We're going to flip to the back and do some more transformations. So let me slide over here. Actually, let me pull this one back up. Let's take a look at example 5. Now, up in this is about group. Let me move this over enough. I want to start talking about what does this formula mean. So I'm going to give you this formula again. Y equals A times B to the x minus h. We'll put that in a parentheses, plus a k. And we wanted to kind of describe again what does this do. All right, so let's first talk about the k. The k will tell you if you go up or down, if we recall from previous chapters. The h will tell you left or right, but what's special about the h is it's always the opposite of what we think. Okay, so a minus h really goes to the right, a plus h really goes to the left. A does a couple of things. If A is greater than 1, it's a stretch. If A is between 0 and 1, it's a shrink. And if A is negative, so if A is less than 0, it reflects over the x-axis. Okay, so those are the things to kind of keep in mind. I'm going to do one question with you, example 5. I want example 6 done on your own. Okay, so example 5, take a look. Let's describe it before we even start. 2 means stretch. The minus 3 at the end means go down 3. And this minus 2, instead of going left 2 like we think it's the opposite, this means go right 2. And so what I want to do, the easiest way to graph these is to graph the parent function first. Okay? And so what I'm actually going to do, let me change colors here a second. What I'm going to do is graph y equals 2 times 4 to the x. I'm going to start with this graph because then all I'm going to do is move these right and down, and I'm going to include the stretch already in this. Okay, so let me make a table for this original. We still use -2, -1, 0, 1, and 2. Let me start with 0. 4 to the 0 power is 1. 1 times 2 is 2. 4 to the first power is 4. 4 times 2 makes 8. 4 to the second power is 16. 16 times 2 is 32. Obviously, we're not going to be able to graph all of these, but that's okay. 4 to the -1 is 1/4 times 2 is 1/2. And 4 to the -2 is 1/16 times 2 is 1/8, which is 0.125. Okay, so here we go. Let's graph what we can. 0, 2, -1/2. This will get smaller and smaller and smaller. 1/8 is like, or way up there, and so I get this graph. Okay. Now my normal asymptote, and I'm not going to do a whole lot with it, but I'm just going to kind of dot that, is at the y equals 0 line. Here's the problem now, and I'm going to switch colors one more time, and we're going to make this bright green one the one we want. What I'm going to do now is take this graph and I'm going to move things right 2 and down 3. So if I take this y-intercept point first, I move this right 2 and down 1, 2, 3. Here's where my new point is. Okay, and then I go, let's go to the next point, 8. If I go over right 2 and down 3, I get to 5. If I take this point and go right 2 and down 1, 2, 3, I get here. And you'll notice I'm moving everything right and down. Well, what about my asymptote? If I move that right 2, I'm still on the same line, but down 3 gets me this new asymptote. And the down part helps me find my asymptote. So my asymptote in this case is y equals -3, and I can kind of complete then my graph. So the green graph is what we're looking for. Now I still was able to put -0 and positives in, so my domain is all reals. My range, if you notice, is above my asymptote, so I say all reals above my asymptote of -3. Now the y-intercept I don't want to use, I want to talk about my starting point, and my starting point was 0, 2. That's where my original y-asymptote was, or y-intercept was. Now take that point, we moved it right 2 and down 3. This is now the starting point that I want. So that's the point to -1. And it's just, what it says to me is, did you understand the original y-intercept and then how to move it? Now what transformations did we have? We said a stretch of 2, right 2, and down 3. Okay, and again, I would like you to be able to tell me the transformation without actually having to graph this. So I want you to try this one on your own. Again, I'm going to ask, really, can you do this without using your calculator? Because we just did that, and we'll practice exponents and things like that. The last thing I want to do is talk about the equations that are there. So let me slide this over. And I'm going to try and get both if I can. Well, we can get a little bit at least. And let me change my color, also get a better color to work with. All right, there are two formulas that you need to know. The first one is general exponential growth, where we have a times 1 plus r to the t. Okay, let's talk about what this is. A is my initial amount. That's the amount I started with. R is the rate, or the percentage rate, as a decimal. And T is the time in years. Okay? So let's do, take a look. In 1970, the population of Kern County, California was about 330,000 people. From 1970 to 2000, the population grew at an average rate of 2.4%. We need to change that into a decimal. So if you divide 2.4 by 100 for 100%, you get 0.024. This now is going to be our R value. This 330,000 is our A value, and they want an equation. Y equals 330,000 times 1 plus 0.024 to the T. Now the question is, how many people will there be in 2020? All right, 2020, we started at 1970, so the time then is going to be 50 years. So we stick it in. All right, 330,000, 1 plus 0.024 to the 50th. All right, you stick that in your calculator. What you should find is you get about 1,080,219 people. Now, biggest thing, you need a whole number because you cannot have partial people. That's the biggest thing going through. Okay, now you've dealt with population growth before, so this should kind of be a review. The biggest thing, R has to be a decimal, so divide your percentage by 100. Time is from the starting point. Okay, last formula, compound interest looks like this. A equals P times 1 plus R over N to the NT power. All right, so let's talk about P is my initial amount in this one. Okay, R is still our rate as a decimal. T is still our time. It's this N that's new. N is the number of times we compound our money, okay? And so we're going to give you some little hints. If N is 1, then it's annually. And somewhere in the phrasing of the question, they'll say annually. If N is 2, they'll say semi-annually. If N is 4, they'll say quarterly. If N is 12, they'll say monthly. I'm trying to think what else they'll give you. If N is 52, they'll say weekly, because there's 52 weeks in a year. If N is 365, it's daily. And so those are the kind of things that you want to look for. Okay, so I'm going to do 1 and 2. We'll save 3 for in class. You deposit $25,900 in an account that pays 3.5%, so divide that by 100. R is 0.035. Find the balance after 2 years. So my time is 2. If the interest is compounded monthly, which means N is 12. So I plug in what I know. 25,900 times 1 plus, my rate is 0.035 over 12 because it's monthly, to the 12 times 2 because it's 12 times in the 2 years. That gets you $27,775.13. Please make sure you round to 2 decimal places. This is the idea. I want you to try 2. We'll do 3 in class as our starter, but I at least want you to get it started on number 2. So these are the 2 formulas we're going to be using. Obviously, the 2 formulas you need your calculators. Okay, thanks for watching 7-1. Again, finish up the graphing questions. I asked you 2 graphing questions, and number 2 here, those need to be completed before you come to class tomorrow.